In this video, I will be showing the Pythagorean identities and how they are derived. Firstly, I will write the equation of the unit circle, which we will come back to later on in the video. The equation of the unit circle is x squared plus y squared equals 1. Then, I will also draw the unit circle on a coordinate plane, just so I can explain some concepts. Unit circle is a circle with radius of 1. That means the distance from the center of the circle to the circumference of the circle is 1 unit. If I project a line from the point where the radius and the circumference meet down to the horizontal axis, we end up with a right angle triangle. And I can call the angle between the radius and the horizontal axis theta. Now I will bring this triangle that we've gotten from the unit circle outside so we can work on it even more. This is 90 degrees theta, and this is 1, which is the radius. I can choose to call the vertical side y and the horizontal side x. Now in trigonometry, we have a mnemonic called SOHCAHTOA. SOHCAHTOA helps us to find the sine, the cosine, and tangent of angles. To derive the Pythagorean identities, we will only need sine and cosine. So from this we can say that the sine of theta equals y divided by 1, and the cosine of theta equals x divided by 1. This implies that x equals cosine theta and y equals sine theta. Having established relationships for x and y, we can now substitute those relationships into the equation of the unit circle. So we can now say cosine theta square plus sine theta square equals 1. And to express this in a much more conventional way, you can write this as cosine square theta plus sine square theta equals 1. This here is one of the Pythagorean identities, and there's 3 of them. This is the first one. The other 2 can be derived from this right one. So let me call this equation 1. To derive the other 2 Pythagorean identities, I would say divide equation 1 by cosine square theta. That means I will be having this cosine square theta divided by cosine square theta plus sine square theta divided by cosine square theta equals 1 divided by cosine square theta. And when we do the algebra, we will have that this cancels out, become 1. Sine divided by cosine is tangent, and 1 over cosine is secant. So we can now conclude that from here we have 1 plus tangent square theta equals secant square theta. This is the second Pythagorean identity. To obtain the third Pythagorean identity, you divide equation 1 again by sine square theta. That means you would now say cosine square theta divided by sine square theta plus sine square theta divided by sine square theta equals 1 divided by sine square theta. Then when we do the algebra, we can now write this as cotangent square theta, because cotangent is the cosine divided by the sine function, plus 1 equals cosecant square theta. The cosecant is the reciprocal of the sine function. So in this video, we've been able to derive the Pythagorean identities. And we've been able to see some key concepts here, such that sine squared theta divided by cosine squared theta equals tan squared theta, cosine squared theta divided by sine squared theta equals cotangent squared theta. So that means the tangent and the cotangent functions are reciprocals. We also saw 1 divided by the cosine square theta equals secant square theta, and 1 divided by sine square theta equals cosecant square theta.